So this question says that we have blood flowing through a coronary artery that is partially blocked by deposits along the artery wall. Through which part of the artery is the flux, the volume of blood per unit time, the largest? So when we look at the concept of flux, we want to say, if we think of a little area here, cross-sectional area, we want to know how much passes this point compared to how much passes that point in a unit time. So the volume of blood per unit time. That's what we call flux. Well, if we think about what happens, if, say, one red blood cell flows in here, so we have one red blood cell that flows through there, that red blood cell eventually is going to have to flow out as well. And if we think about this, for every one red blood cell that flows in, one has to flow out. Otherwise, we'd start to build up blood cells here. And if we let this thing to hit its normal working condition, its steady state flow, there's going to be no buildup of blood cells anywhere in here. So if the blood flows through this area right here, then it's going to have to flow there. If we have one blood cell per second, then we have one blood cells per second here. We have 3 blood cells that flow through here. We're going to get 3 blood cells that flow through there as well. So what's going to happen is that the flux, the amount of mass, or amount of volume of blood per unit time is going to be the same. This is actually just the continuity equation. And really what the continuity equation says is that we don't build up fluid at any point in our pipe, or in this case, our artery. If we did, bad things would happen, and that's not actually what happens. So continuity equation tells us that we get the same flux through both parts. That's not saying that they have the same speeds or the same pressure, but they do have the same volume per unit time.